Good morning, dear participants. I hope you are doing well. Today, we are going to discuss a very little overview of the benefits of and features of Geolog 7 for formation evaluation. So let's start. Before discussing the various features of Geolog 7 and basically for the purpose of formation evaluation and petrophysical interpretation, we will make a very short overview about the EBOS infrastructure upon which the Geolog has been based. Here's the various software solutions developed by Paradigm to cover different fields of exploration and development. We have, for example, some software packages that have been developed for the purpose of reservoir characterization and petrophysics, like Geolog, StatImage, Vanguard, and Next Model. We have also for data processing and imaging the geodepth focus, probe surveyor, and for visualization and interpretation, and earth modeling, the voxel geo and the reservoir navigator, size X, and also various other software for the well planning and drilling. These will complete the cycle of solutions that have been developed starting from advanced seismic processing until reaching well planning, geosteering, and drilling. So about EBOS infrastructure or EBOS system, it provides data repositories optimized for engineers and petrophysicists, designed for complex structures and large data volumes, can host data for large spectrum of applications and disciplines. Also, it can be regarded as a middleware framework supporting distributed data management, multi-vendor, multi-data model, multi-platform, and independent of repository architecture, and also simple access using a powerful application programming interface. It can support data management applications, administration of projects, repositories, users, and groups, browsing tools for broad multi-vendor networked repositories. So let us focus into Geolog 7, one of the basic software solutions based on EBOS infrastructure. So basically, a Geolog has been focused and developed for the purpose of petrophysics and formation evaluation, but also it has been expanded to cover solutions of other more wide geoscientific and engineering solutions like modeling, geology, and geophysics. Here's some examples about the outputs of the analysis conducted by Geolog 7, and also shows some of the modules of the Geolog 7. For example, the deterministic module of Geolog 7, also output of multi-man module, petrophysical uncertainty, lithophages and photos, geomechanical analysis, pool pressure and fracture gradient, also the biostrat and the bit depth, the texture analysis, the nuclear magnetic resonance processing and interpretation, reservoir classification, and the module for unconventional shape plays, sonic waveform, and interpretation. These are some examples about the output of Geolog of analysis by Geolog 7. So let us discuss now the basic features of Geolog 7. First feature is being a vendor neutral solution. Second, it is characterized by a user-friendly interface, having a user-friendly interface. As you see, we have basically 5 applications: the project application, the well application, a section application, the GUC application, and the artist application. Basically, a project application is for importing data. Well application for conducting the different analysis, whether it is petrophysical analysis and also the geological and some of geological analysis can be conducted. Section for generating the subsurface sections, geoseeing for logging while drilling, and we have the artist application. These are the basic applications in the Geolog user interface. So also another feature is being a platform independence and its flexibility with dealing with the data import and export. Another feature is its easy to use environment for log processing and editing and interpretation, and having powerful cost plotting tools, including interactive 3D cost plots, providing input for petrophysical calculations. And presentation quality graphical output, comprehensive petrophysical, having a comprehensive petrophysical processing tools. Also, it has cross-section creation tools in the geological package, multi-well, multi-zone data management, sophisticated petrophysical and geological analysis tools, well data management, superior graphics, and robust data integration. Also, it is characterized by a short learning curve and comprehensive data analysis. Geolog also minimizes the black box nature of other petrophysical software. Users have access to the most comprehensive toolset available for exploration and development geologists. Here's an example of view of well bore in 3-dimensional generated in Geolog. And any combination of Geolog's graphical displays can be presented within a single workspace. It enhances the productivity and efficiency because it provides smoother and more efficient workflows to cross-disciplinary assist teams and enable petrophysicists and engineers to identify the specific flow units within reservoirs and estimate their flow capacity, and also leverage best-in-class well-put data analysis platform for geological interpretation workflows. Characterized also by reservoir characterization plots and new functionality to quickly estimate reservoir flow properties from log data and identify flow units and estimate their production capacity. The integrated 3-dimensional visualization and mapping, and this improve understanding of the 3-dimensional architecture of our reservoir. Better reservoir characterization through shared knowledge. The reservoir characterization functionality that allows petrophysicists and engineers to estimate reservoir flow properties and their production capacity, accessing well data from a single source and close collaboration between petrophysicists performing reservoir characterization and geologists working in interpretation and earth modeling. Field-wide quality control work. Map-based tools help maximize the returns from a study by managing pertinent information effectively and easily. An example about field-wide property mapping created in a Geolog project. The automatic report generation using customizable templates, the powerful data management capabilities with a full audit trail with the ability to query the history of any individual log, supporting for multi-user environments, a single integrated environment for petrophysics, borehole geophysics, geology, and borehole engineering workflows, and a tool for both the generalists and specialists. Also characterized by the petrophysical solutions for unconventional plays and especially unconventional shale plays. Also characterized by the Monte Carlo uncertainty assessment that is available in all modules of Geolog. The log-based pressure and fracture pressure prediction, and the unmatched module customization and the connectivity options, the freedom to customize modules of log analysis, and the Python scripts can be created in Logline. Logline is the programming language for Geolog. So Python scripts can be created in Logline editor and run from Geolog, and this is one of the most important features of Geolog. A new and improved functionality that add value in every domain for petrophysicists, geologists, and engineers. This expands the product's reach into additional phases of production cycle and fully integrated workflows that enhance multidisciplinary assist teams' productivity and efficiency. The direct access to third-party databases that saves time and money. The EPOS framework allows Geolog applications to work directly not only from the data stored in EPOS World Data Repository, but also on such databases as Petrel. There is two-way connectivity between Geolog 7 and Petrel versions 2015 until version 2020. So there is two-way connectivity, import and export. Recall full interoperability of recall connector and GeoFrame 2012. Another important feature of Geolog 7 is the new data import format supported. There is a support for various formats that can be acceptable by Geolog, like, for example, Petra log image calibration, the extension LIC, and OWX as exported by Kingdom, the geographics ASCII4 also that format, IHS 298 production data, the 3D code data, the 3D code data DCOM format, MATLAB, and Python. So let us now focus into the Geolog geoscientific packages here. Before discussing the geoscientific packages and the various modules in this package, we would like to make a very little review about some valuable Geolog tools like the evaluate tool and the parameter picking tool. Basically, the evaluate tool, as we will see, can be used for various tasks, and it is the most widely used tasks for evaluate tool for setting limits for computed original logs, creating computed logs from other logs, creating flags. And we will see a demonstration about the evaluate. So let us make a little demonstration about these tools and go back after that to our presentation. So let us open Geolog. So here's the user interface of Geolog. As you see, we have basic 5 applications: the project application, well application, section application, GC, and artist. So project is basically for importing data. So before choosing project, we have to define a new project. So from file, new project, and we have to set a name for that project. For example, test 61, and okay. So let us now open the project. Here's a project for importing our data. There's several methods for importing data. For example, the standard file importer for importing various types of data involving the LAS files, ASCII, and also can import images. The custom text importer for importing the formation tops. We have various methods of importing data. We will quickly make an import of our data here. So basically, we can use standard file importer, and then we drag and drop, just drag and drop your file. This is the well file in LAS format. I will drag and drop this file here, and then check on the set. In this file, we have different wireline locks. So I will set the set into wire. Define the set into wire, and okay. And let us examine the various logs included in this LAS file. Here's a list of the different logs included here. We have the PET, the caliber, the neutron porosity, the sonic, delta T, gamma ray. We have various logs for resistivity, M2R1, M2R2, M2R3, M2R6, M2R9, M2RX, the PEF, the flash zone resistivity RMSR, the spontaneous potential, density correction, and finally the density log. If you would like to use another units rather than the input units, you have to define these units here. For example, in the last file, the density is presented in gram per cubic centimeter. This is in last file per cc. And also we have the density correction will be gram per cc. And about RMSL already in ohm meter, so I guess the other units is okay. So here we can import these logs. So it has been finished importing. So the second, after importing these logs by using the project application, we go to the well application, open the well application. Now here's the well application. You can see in the well application the basic geoscientific packages. You see the petrophysics package, the geological package, the geophysical package here. There is a tab for each package presented here. And so you can make overview or you can select your suitable package with a petrophysics, geology, geophysics. So we will start by making a new layout. So here's a new layout. First, we have to check that our last file have been imported into the well application. Our last file is called training, so we will import it, select it and import it here, and okay. So now it is so easy to draw your logs. Just insert wire line. Just insert wire line, and then double click at the header of this wire line to insert your logs. So I will insert log here and select your suitable log, for example, the gamma ray log, okay. And the set will be wire, okay. And then apply. And insert another log, like for example, the caliber, okay. And you have to check also the units seen here. The units for caliber is from 6 to 16 inch, and the units will be inches, and the set is wire, okay. So this is the caliber. You can also adjust the color, any color you would like for your log, and then you can insert the bit size, okay. Let us make it in green, for example, okay. Insert caliber, okay. Wire, okay. So this is the caliper, and then you can insert also the SP, spontaneous potential. Insert, look, spontaneous potential, okay. And you can adjust your color. For example, I would like to make gamma ray in green, okay. The bit we can make it in black, okay. Caliber, we can make caliber for example in red, okay. And SP, we can make SP in blue, and then apply, okay. So we have inserted the first track involving the bit, the caliber, log, gamma ray, and the spontaneous potential. Also, you can insert the other tracks, the resistivity logs, and neutron and density logs, and delta T logs. So let us now Let us now make a view about the value of the evaluate tool. So you can find evaluate in the general window. You can see the general window. You just select evaluate, double click on evaluate to access this tool. So we just double click on evaluate to access the tool. Here is the window of evaluate. For example, we have seen that there are different tasks that can be done by evaluate. Let us test a few of these tasks here. So let us, for example, we can make, for example, a flag for sand. So depending on gamma ray, so I will select, for example, gamma ray as a sampling block. And you have various expressions in the value column. So you just double click on the value column to find different expressions, and numeric, string, logical, miscellaneous. Double click on numeric to expand these various expressions. You have these various expressions that can be applied to your logs. So let us, for example, choose the FC expression here. So this is the FC expression. Here's the formula for FC expression. This valuable expression can be used also for making a flag. For example, the flag is having either of 0 or 1. The flag only has one of two values, either 0 or 1, on or off. So let us, for example, see if gamma ray is less than 35 ABI, then make it sand. So it make it one as sand flag. So this makes a flag for sand. And if else it will be 0. So and click OK, and just make a name for the log output. For example, I will make it as sand flag. And then after completing this, you will press on the start button. Now the module evaluate has been finished. Let us now see what is the result. We will double click to insert a new log. So let us search for a log called S flag. Here is the S flag, as you see. This is the sand flag we have already created by selecting gamma ray less than 35 ABI. So the left scale will be 0, right scale will be 1. Any flag will have only either 0 or 1. So let us make, for example, shading, the left shading to left limit to be sandy shading. Okay. And we have from 0 to 1. So this set will be a wire. Okay, and apply. Okay. You can see now how we can identify and market the zones or intervals having gamma ray less than 35 as being sandy intervals here. So we have discriminated these intervals from the other intervals, just for example to focus on this interval in our analysis. So this is an example of using the evaluate module here. Also another example, we can create a new log from some logs. For example, we can create from density or ZDNC. Okay. We can create, for example, Young modulus from density and delta G sonic. So just double click on value to open or to access the expression builder. And now you can choose numeric. Just you can type, for example, your equation or expression, rho B, this is the density rho B subdivided by delta T to the power of 2, and okay. And then you have to rename your output, for example, as Young, and then start your module. So module has been finished now. So let us see the results here. Just I will insert a new wire line and double click on the header and insert the log and search for Young. Just search for Young. Here's the wire Young created from density and delta G. Let's choose a color, for example, a color blue. Okay, apply and okay. So you are now seeing the wire, the Young modulus by this expression here. So these are just examples for using the evaluate tool. Also another application of evaluate tool when conducting certain petrophysical analysis, you can set a limit, some limits for the output. For example, when we conduct the V-shale estimation or V-shale computation from gamma ray, you can set a limit for V-shale to be between 0 and 1 only. Since there is no V-shale larger than 100% and there is no V-shale is smaller than 0. So you can set a limit for the output also by using the evaluate module here. So this is just example of using evaluate module. Let us now move to the parameter picking. We can conduct parameter picking in two ways, either in the frequency plots or the cost plots. Parameter picking is a valuable tool for selecting new parameter required for the petrophysical analysis equations. Like, for example, when using the gamma ray for evaluating the shale content or the shale volume, you have two basic parameters. This is the gamma ray of matrix or gamma ray clean and the gamma ray of shale. These two parameters are required for solving this equation. Also, for example, when you solve the saturation equation, you have the parameters of the A Auschwitz constant, M segmentation factor, and N saturation exponent. Beside RW, the formation water resistivity, and mud filtered RMF mud filtered resistivity. So parameter picking is valuable tool for selecting new parameter required for to be input into your equation to be solved. So I will make a new frequency plot, for example. Here is a new frequency plot. We just define this plot, double click, and then choose Geolog. For example, I will select gamma ray. Here's wire gamma ray, okay. And then you can adjust your scale from 0 to 200 API. And then click apply and okay. So here's the frequency plot of the gamma ray is presented here. So to select your parameter, parameter picking is found here in the petrophysical package. So I will right click and insert point and make a name of this point. For example, I will insert matrix point and okay. Just I will, okay. Here I will insert the point and name it as matrix, okay. And just choose your position. For example, for minimum gamma ray, I can use this position as a minimum gamma ray. So here's the matrix point. And after that, I will confirm that I will choose this point as being the gamma ray matrix or gamma ray clean, and then okay. So this point has been saved as being a matrix point. So let us insert a new point, and it will be the shell point, and point to the maximum gamma ray, for example, in this position here. And then after, to confirm, just click OK to confirm selecting this point as a shell point. So you have picked the parameter for the gamma ray matrix or gamma ray clean and gamma ray shell. Just you can find the exact values here. When you expand this arrow, you can find the values of gamma ray matrix and gamma ray shell. These are the basic values you can select from by using, for example, the frequency plot. So this is an example about using the parameter picking. So moving now, returning to our presentation now. So returning to our presentation now, we have discussed the value of evaluate and some examples of evaluate and parameter picking. Here is the basic Geolog geoscientific packages. The Petrophysics package, the geophysics package is called Synthesize, the geological package. Petrophysical package has very variable modules. It has, for example, the quicken module, quick analysis. Deterministic module, it is called determine. The deterministic uncertainty also. The multi-min or multi-mineral analysis. The fish image for image processing and interpretation, and for the electrophysics extraction, the nuclear magnetic resonance, and the full wave sonic modules. Regarding geophysics, we have, for example, the well-time module, the synthetics module, the amplitude versus offset synthetics, the rock properties, fluid substitution, or pressure prediction. Regarding geological package, we have well correlation, whole image logs, textual analysis, automatic deep calculations, and the stereo nets. Let us focus into the petrophysical package. Here is the basic components. We have quicken module, determine module, determine uncertainty module, multi-min module. Also, we have illuminated Cayley sand analysis module, nuclear magnetic resonance module, full wave sonic, and also a module for conducting or analyzing Gaussian logs. Here is the various output. We can output the lithology, porosity, water saturation, permeability, and finally we can make pH summary. So here's before the basic modules discussed here. This is the data preparation step. The data import, whether wireline data or code data or matlogs imported. And then we make QC and editing data. For example, curve inserting or despiking, baseline shift. These various processing tools are found in the well application in Geolog. And then the pre-calc or pre-calculations to estimate formation temperature and pressure profiles, or generate formation temperature and pressure profiles, to fill the mud properties, the salinities of mud filtered from sample measurements, mud cake thicknesses for process safety and porosity tools, photoelectric absorption cross section, and the conductivities of unflushed and flushed zones. And then the fourth step is the environmental corrections based on the types of tools and the versions of these tools. So here's the Petrophysics package as it is shown here. We start by pre-calc and then the environmental corrections and